Hello growers, I'm Dr. MJ Coco from CocoForCannabis.com. I conduct independent grow light tests as part of our comprehensive grow light guide. I have another big one, the Mars Hydro FC-E8000. It's a large 800 watt LED grow light designed for 5x5 coverage, or 4x4 coverage with supplemental carbon dioxide. It's similar in design and performance to the Mars Hydro FC-E8000, which I tested 2 months ago. Last month, I did a video comparing 9 different 5x5 fixtures to see which is the best. The Mars Hydro FC-E8000 came out on top, but I had not tested the FC-E8000 at that point. So when I got it, I ran the FC-E8000 through the same PAR and ePAR tests that I did with the FC-E8000. We'll look at all those tests side by side, and you can see how close they are in performance. However, they're not that close in price. The FC-E8000 costs $200 less than the FC-8000. For the best price for either fixture, use discount code CCFC on MarsHydro.com. The FC-E8000 is one of the best deals on the market, but one lucky grower will really get the best deal. I'm giving away the one I tested for free. If you're watching during the live premiere on YouTube, guess the 3-digit winning number and put it in the chat. If you missed the premiere, be sure to subscribe to my channel so you don't miss the next one. The Mars Hydro FC-E8000 is similar to the FC-8000 in many ways. They both have 8 adjustable LED bars. They arrive disassembled, and the spacing between the bars is adjustable. This design cuts down on shipping costs and enables greater adjustability. The most significant difference between the FC-8000 and the FC-E8000 is the diodes. I'll check them out in a second. In addition to the 8 LED bars, we have a hanging kit together with an RJ cable. Here's all the hardware to put this thing together, and the cables are already connected to the large SOSUN driver. Let's see, I almost forgot the 2 frame pieces. Okay, let me lay everything out. The driver is from SOSUN. It's the exact same model that they use on the FC-8000. The 8 LED bars will be supported by the aluminum frame pieces on each end. There's the hardware, manual, and hanging kit. Like I said, the main difference between the FC-8000 and the FC-E8000 is the diodes. The FC-8000 has the well-known Samsung LM301B, while the FC-E8000 uses a ton of Bridgelux diodes. Based on the stats, the Bridgelux diodes should perform similarly to the Samsungs, but they're less expensive and help give the FC-E8000 an incredible price. We'll see how they perform in my tests. Let me put this thing together. I got the 2 frame pieces laid out, and I'll get the hardware ready. The assembly process is pretty straightforward. I just have to lay all 8 bars on top of the frame pieces and screw them into place. The assembly process takes only about 5 minutes. If you want to see it in more detail, check out my PAR test and review video with the Mars Hydro FC-E6500. I got the bars screwed down, the eye bolts screwed in, and the corner protectors inserted. Now I just have to attach each bar to the octopus cable. Just push and twist. This cable allows the flexibility to slide the bars along the track. They provide hanging cables and 2 ratchet pulleys, but I'll use 4 ratchet pulleys for my PAR tests. I'll clip them into the eye bolts I attached to the frame. I'll raise one side, and then the other, and I got it hanging up. I plugged it in, let me turn it on. There really are a lot of diodes on this fixture. I thought the diode count was good on the FC-8000. It has 2,968 of the Samsung diodes, which is 3.71 diodes per watt. This FC-E8000 has almost 1,000 more. It has 3,928 of the Bridgelux diodes, which is almost 5 diodes per watt. Both the FC-8000 and the FC-E8000 have full spectrum diodes at 3000K and 5000K, along with 660 nanometer deep red diodes. It's a common combination, which creates an excellent spectrum for indoor horticulture. I need to let them all warm up before the tests. Let's check out the published stats. This is the product page for the FC-E8000 on MarsHydro.com. You can see the current price is only about $660. We have a discount code that will get you the best price. Use discount code CCFC. Like the FC-8000, the FC-E8000 is an 800 watt grow light. Mars Hydro markets both fixtures for 5x5 or 4x4 coverage, and they suggest the use of supplemental CO2. So I'll run the same 4x4 and 5x5 tests that I ran with the FC-E8000. In this image, we can find the efficiency. They claim 2.7 micromoles per watt. Before I run the tests, let's run these numbers through the Coco for Cannabis grow light calculator. This is our tool to help growers analyze grow lights. It focuses on the important metrics and allows you to make better comparisons. In the calculator on the right, I load all the fixtures that I test. I'll pull up the data from the Mars Hydro FC-E8000. It has a superior usable photon efficiency of 2.34 micromoles per watt. With discount code CCFC on marshydro.com, the current price for the FC-E8000 is about $834, which is only 45 cents per micromole. These are excellent numbers. Let's see how the data from the FC-E8000 compares. The published power draw is 800 watts. With discount code CCFC, the price is only about $640, and I assume the efficiency data is from a Mars Hydro in-house sphere test. I'll select Total PPF and enter the published efficiency, 2.7. Wow, that's almost a perfect match, for everything except the price. The calculator predicts the FC-E8000 will get the same photon efficiency as the FC-E8000. The slight discrepancies in usable PPF, coverage area, and harvest estimate are a result of the slightly different power draws. But the difference in price is significant. If these estimates are confirmed by the tests, the Mars Hydro FC-E8000 is one of the best deals on the market at only 34 cents per micromole. Let's see. I have the Mars Hydro FC-E8000 set up in a 5x5 space. I adjust the hanging height to get the maximum PPFD to be exactly 1,000 micromoles per square meter. The FC-E8000 hit that density limit at a hanging height of 59 centimeters, about 23 inches above the sensor. That's 1 centimeter higher than the FC-E8000. I set the hanging height based on the maximum PPFD in the PAR range, 400 to 700 nanometers. I'm using the Apogee SQ500 PAR sensor, which measures exactly that range. I'll also run an ePAR test with the fixture in this same position, but let's check out the PAR map first. This is an excellent PAR map. The maximum PPFD is 1,000, and the lowest corner is up at 570 micromoles per square meter. There's an excellent spread of light in the maximum production zone, from top to bottom and from side to side. This map is strikingly similar to my official PAR map with the FC-E8000. Let's look at that map. Not much changed. There's a touch more light in this map, and the lowest PPFD is 27 points higher. But as I flip back to the FC-E8000 map, you can see that the distribution and photon densities are almost the same. We'll see just how close they are when we run the numbers on this test. The data from the FC-E8000 official 5x5 PAR test is on the left. Less than a month ago, I rated it the best 5x5 grow light overall. It's going to be tough to beat, but the FC-E8000 map on the right is going to be close. I had to hang the FC-E8000 at 59 centimeters, 1 centimeter higher than the FC-E8000, to get the same maximum PPFD of 1,000 micromoles per square meter. The FC-E8000 delivered an average PPFD of 781.6 micromoles per square meter, which is just slightly lower than the FC-E8000. The lower average means a slightly lower usable PPF, 1,758.5 micromoles for the FC-E8000, which is just 1.5% less than the FC-E8000. It's actually a bit closer than that, because the FC-E8000 drew 783 watts, which is slightly less power. In terms of efficiency, they're almost the same. The FC-E8000 produced 2.26 micromoles per watt, and the FC-E8000 produced 2.25. If you think these results are close, wait until you see the ePAR numbers. Last year, Apogee released the new SQ610 extended PAR sensor. It measures the density of ePAR light from 400 to 750 nanometers. That encompasses the PAR range plus far red. I run the official ePAR test with the fixture in the same position as the official PAR test. For decades, PAR light was thought to be the only light that powers photosynthesis. However, cutting-edge research with lasers and advanced LEDs is demonstrating that far-red light from 700 to 750 nanometers is also photosynthetically active. The FC-E8000 and the FC-E8000 don't have any diodes that are dedicated to far-red light. However, the full spectrum and 660 nanometer diodes emit a small portion of their energy in the far-red wavelengths. We'll be able to see how much far-red these Bridgelux diodes emit and how it compares to the Samsung Osram combination on the FC-E8000. Let's check out the 5x5 ePAR map for the FC-E8000. That's an even better looking density map. The lowest density in the ePAR range here is exactly 600 micromoles per square meter, which is really good for a 5x5 map. If we look back at the PAR map, of course, the densities go down. We count a smaller range of light in this test. When I flip to the ePAR map, the densities in every square go up by about 30 points. Let's see how this ePAR map from the FC-E8000 compares to the ePAR map from the FC-8000. Wow, that's really close. The values ticked up slightly along the edges, but they ticked down slightly in the middle. This is going to be close. Let's run the numbers. Again, I have the map and data from the FC-8000 on the left, and we'll fill in the data for the FC-E8000 on the right. I hung the FC-E8000 at 59 centimeters above the sensor. That's 1 centimeter higher, but the maximum ePPFD was also higher, at 1,035 micromoles per square meter. The average ePPFD was 813.2 micromoles per square meter, which is just a hair less than the FC-8000. Therefore, the usable ePPF is also just a touch lower. The FC-E8000 delivered 1,829.7 micromoles of usable light to the canopy. But the power draw was also just a little lower. The FC-E8000 drew 783 watts. So the photon efficiency is exactly the same, 2.34 micromoles per watt. The ePAR tests are even closer than the PAR tests. The FC-E8000 made up some ground when we counted far red. If we take these ePAR maps and subtract the values from the PAR maps, we can evaluate just the far red light. Most of this light is being emitted by the full spectrum diodes on each fixture, and you can see the Bridgelux diodes emit slightly more far red. The FC-8000 with Samsung and Osram diodes delivered a total of 59.9 micromoles of far red light, which is 3.25% of the total flux. And the FC-E8000 with Bridgelux diodes delivered 71.2 micromoles of far red light, which is 3.9% of the total flux. Both of these fixtures produce plenty of light for most growers in a 5x5 space. But Mars Hydro also asked me to run some tests in a 4x4 space. I set up the same tests that I ran with the FC-8000, with a hanging height of only 12 inches, 30.5 centimeters above the sensor. I started with a PAR test using the Apogee SQ500 sensor, and then I ran 3 ePAR tests with the Apogee SQ610 sensor, one at full power, and then with the dimmer dial set to 75%, and finally 50%. The FC-E8000 is the same size as the FC-8000, and it's a tight fit in a 4x4 space. But having the fixture practically touching the walls should lead to an excellent distribution. Let's check out the maps. First, we have the PAR map with the 400 to 700 nanometer light. This is a lot of PAR light packed into a small space. The light is too dense for plants unless there's supplemental CO2. Without it, the maximum safe density is 1,000 micromoles per square meter, and even the lowest corner in this map is well above that. For growers with supplemental CO2, this map is close to perfect. The densities are high, and the distribution is very even. And again, it's very similar to the map generated by the FC-8000 in the same test. If you have sharp eyes, you notice the values around the edges went up when I flipped to this map, and the values in the middle are slightly lower. The overall amount of light is almost exactly the same, but the FC-8000 here is slightly better distributed than the light with the FC-E8000. But it would be fair to say this is splitting hairs. These are both great density maps. Let's run the numbers and see how close they really are. I set the same hanging height for these tests, 12 inches, 30.5 centimeters above the sensor. The FC-E8000 had a higher maximum ppfd at 1,384 micromoles per square meter, but it also had a lower minimum ppfd and a slightly lower average at 1,268.3 micromoles per square meter. The usable ppf is slightly lower as well at 1,326.3 micromoles. But the power draw was also lower with the FC-E8000. It pulled 782 watts during this test. So the FC-E8000 has a better usable photon efficiency, 2.34 micromoles per watt. With a better distribution and a touch more light, the FC-E8000 has the better PAR test result. But it's very close, and that advantage may not hold when we consider the ePAR tests. The FC-E8000 produces a little more far-red light than the FC-8000. The maximum ePPFD was 1,443 micromoles for the FC-E8000, but the FC-8000 still has better values along the edges and corners. Despite that, the FC-E8000 has a slightly higher average ePPFD at 1,327.8 micromoles per square meter. That means it delivered slightly more light to the canopy. The usable ePPF is 1,912.1 micromoles, and the power draw was 782 watts. So the FC-E8000 had a higher usable ePPF despite having a lower power draw, which means it has the better efficiency at 2.45 micromoles per watt. So which of these lights has the better performance overall? That's a pretty tough call. I can say that the FC-8000 has slightly better distribution, and the FC-E8000 produces slightly more far-red light. Other than that, this is basically a tie. They're both excellent fixtures. After the ePAR test at 100% power, I ran full ePAR tests with the dimmer knob set to 75% and 50% power. At 75% on the dimmer knob, the power draw was 577 watts. The maximum ePPFD was 1,098 micromoles per square meter. That's still a little strong for grows without supplemental carbon dioxide, but dimmed to about 550 watts would be safe. The average ePPFD here is incredible. It's 1,011.1 micromoles per square meter. The distribution is excellent. There's very little difference from the maximum to the minimum ePPFD. At 50% on the dimmer knob, I measured a power draw of 314 watts, with a maximum ePPFD at 620 and a low corner up at 476 micromoles per square meter. This map has perfect density light for early vegetative growth. Looking at these three tests together, we can see how the usable photon efficiency goes up as the dimmer setting goes down. Diodes are more efficient at a lower power draw. That's why we pay attention to diode count and diodes per watt. The FC-E8000's high diode count is the reason it can compete so well with the FC-8000. We can learn a lot by studying these data. I publish all of them in the test report in the Coco for Cannabis Grow Light Guide. Here are the main data for the Mars Hydro FC-E8000 in the 5x5 ePAR test. For grows without supplemental carbon dioxide, we rate it for over 28 square feet and estimate a harvest potential of almost 50 ounces. Here you can find our discount codes and shopping links. For the best deals, shop marshydro.com and use discount code CCFC. Right now, the cost will come to about $640, which gives it a cost efficiency of only 35 cents per micromole. That's among the lowest prices on the market. We saw that the performance was nearly identical with the FC-8000. It's a great deal too, but you save almost $200 if you get the FC-E8000. So 200 is the winning number in the PAR Test Premier giveaway. Congrats to whoever guessed the closest number. And if you missed the premiere, be sure to subscribe to my channel so you don't miss the next one. Below the test data and the growth space calculator, you'll find my written review. When I compared the Mars Hydro FC-E8000 to 8 other 5x5 lights, it came out on top. But if I had tested the FC-E8000 at that point, the rankings may have been different. The FC-E8000 can go head-to-head with the FC-8000. They're both among the best lights on the market for 5x5 coverage, and they can both evenly distribute ultra-high density for 4x4 grows with supplemental carbon dioxide. The FC-E8000 has many more diodes, and it ran a few degrees cooler than the FC-8000. The ambient temperature during my test was 24 degrees Celsius, 75 Fahrenheit. The LED bars on the FC-E8000 hit a maximum temperature of 50.8 degrees Celsius, 123.4 Fahrenheit. The driver, which was detached from the fixture, hit a maximum temperature of 57.9 Celsius, 136.2 Fahrenheit. The Mars Hydro FC-E8000 is a powerful grow light with top efficiency and excellent distribution. It nearly matches the FC-8000 photon for photon. The price makes the FC-E8000 an easy choice. In the current market, you could pay a lot more and get a lower quality light. At Coco for Cannabis, we always put the grower's interests first. Our goal is to provide impartial, science-based testing and reviews for home growers. You support our work when you use our discount codes to purchase grow lights. I'd like to thank Sean at Mars Hydro for sending me the FC-E8000 to test. And thank you for watching. Please give the video a thumbs up and subscribe to my channel. Turn on your notifications so you don't miss the next PAR Test Premier giveaway. Learn about all our grow light giveaways on the Deals and Discounts page at cocoforcannabis.com. While you're there, you can read our articles, chat with our community in the chat room, join our next Grow Challenge, and try your hand at the Grow Light Calculator. Grow your own, but don't grow alone. Let's grow together. I'm Dr. MJ Coco, sending all of you grower love.